Hello everyone. In this video, we'll understand about how do we do a factor analysis uh, in a marketing research, right? Basically used in marketing research. Yeah. This particular concept we will understand through an example. So here is a question. The marketing manager of a two-wheeler company designed a questionnaire to study the customer's feedback about its two-wheeler, and in turn, he is keen in identifying the factors of his study. So the variables what he has identified are fuel efficiency, which is calling it as X1, life of the two-wheeler, calling it as X2, handling convenience, X3, quality of original spares, X4, breakdown rate, X5, price, X6. So what he did is that the company administered the questionnaire among 10 customers to obtain their opinion on the above variables. The range for each of the above variables is assumed to be between 0 and 9. Means if the customer is very much pleased with a particular variable, he will be ranking 9, and the least score he will be giving is 0. So the low rating is 0 and high rating is, sorry, let me change it to 9. High rating, right? So based on this, he got a data collected as below. The data is given here. What we are supposed to do is to perform a factor analysis using Centroid method. This method is called as, whatever method we are going to use now is called as a Centroid method. And using that method, we are supposed to identify 3 factors which can represent the variables, all these variables of the study. So we have to bring it down from 6 variables to 3 factors. So how do we do it? So these are the customer's rating given for each variable. For example, respondent 1, he has given rating of 6 for variable 1. What does it mean? Fuel efficiency, he rated it as 6. Then life of the vehicle, he rated it as 8. Handling convenience, he rated high, 9. Original quality of spares, he rated it as 9. And breakdown rate, he rated it low, it is 1. Pricing also he has rated low, which is 2. So likewise, every respondent has done their rating. And this feedback is obtained from 10 different respondents. So this is the question. How do we do the factor analysis? One thing is clear, number of variables, which we denoted by small n, is 6. There are 6 variables, x1 and 2, x6. Okay. Number of sets of observations. How many respondents? There are 10 respondents. And how many factors we are supposed to identify? 3 factors. So f is equal to 3. Initialize the current factor number. F small f equal to 1 means since the number of factors to be identified is 3, we may go for 3 different iterations. So we call it as iteration, 3 different steps we will be adopting. First thing is we will be finding out the correlation between each pair of the variables. So if you look into, there may be what do you call, since there are 6 variables, every variable will be compared with the other variable, and we will be finding out the correlation. That means for a pair you need 2, so 6C2 will be there. 6C2 correlation coefficients we will be obtaining, which means it is 6 into 5 by 2, or 15 correlation coefficients we will be obtaining. For example, correlation coefficient between x1 and x2. Suppose if it is R12, then R12 will be the same as R21. What is R21? R21 is x2 and x1. And similarly, correlation between the same variable will always be 1. X1 and x1 will always be 1 because you are going to compare with the same data. For example, if I consider x1 as this, again x1 as this, and if I try to find out correlation, the correlation coefficient will be 1 only. So based on that, we will create a correlation matrix like this. Means if you look into, diagonal elements will be 1 because this is a correlation between x1 and x1, x2 and x2, x3 and x3, x4 and another one more thing you may notice is you found x1 and x2 correlation coefficient as 0.742. Same thing will be there for x2 and x1 also. Means below the diagonal and above the diagonal, the numbers will be the same. The correlation coefficients will be the same. Right. So How do we find the correlation coefficient? We can use our Microsoft Excel sheet wherein you can feed in these data in one column, and then we can select these data points together and find out directly the correlation coefficient. So that is possible because manually it will take a lot of time to find out the correlation coefficient. So you can use the Excel sheet to calculate the correlation coefficient, wherein we use CORREL, that function we can use, right, for finding out the correlation. So using MS Excel function equal to CORREL, then we can choose the data point range. For example, in this case, from here to here, this data point, I can feed that in this area, and whatever I want to compare the next one, for example, this, I can select this range and put it here. So immediately you may get in that particular cell, wherever you type this, you will get the value of the correlation coefficient in your Excel sheet. Now, after evaluating the correlation coefficient for various things, you may notice that all numbers are not positive correlation. There is some negative correlation also. That's why you say here, since the above matrix R1, we are calling this matrix as R1, is not a positive manifold, means everything is not positive. The variable x6 is reflected. Reflection means the negative values are to be converted into positive values. If you look into where all negative values are occurring, here you may notice x6 is having, here also x is having, that means except for x6, rest of the other elements are having a positive correlation coefficients. So we say x6 is reflected, we will be reflecting it. Means we will be converting those negative values to positive values by taking the, considering the absolute values, means modulus of all those things. We call this as weights of the variables, that is the columns from 1 to 6, or wherever positive is there, you call it as weight 1, and wherever negative is there, you call it as weight -1. So that if I multiply this by 1, it will remain positive only, whereas this will become positive again because you are multiplying it by -1. So you basically, we are trying, when you say reflection, we are trying to convert the negative values to a positive values. Then the correlation coefficient matrix with reflections on the variable x is as follows. We call this as R1 dash. Instead of R1, we call it as R1 dash. Same numbers only I wrote. Instead of negative signs, you will have positive signs. Then the next step is add all these values, column wise totals. So you say sum of column J means sum of column 1, sum of column 2, sum of column 3, like that. Then sum of all these column totals will give you the grand total, which we are calling it as capital T. So the grand total of column totals is capital T, which is nothing but sum of all this SJs. You get 15.786. The next step is to find the square root of this grand total, which is 3.973159, square root of 15.786. Then next step, we have to find out the, determine the loadings of factor 1, which we call it as L1J, or summarized in the below table. For this, what we need to do is, first you have to find out unweighted factor loading. So you say UL1J. How do you calculate that? SJ, you have all the column totals here, these totals, that you write it in the column like this. For J1 equal to 6, what are all the SJ values? Then you can calculate this UL1J. How do you calculate? SJ divided by square root of that grand total. So you do that, means 3.320 divided by 3.973159. That we are doing it for every value, you are dividing it by this value to get this unweighted factor loading. After that, what you weighted factor loading means, we already decided 111, this weights 11111 up to 5 columns. Then the last column is -1. So you bring back that weights to that, means you multiply these first 5 as with the +1, last one will with -1. That's why you again go back to negative sign here, that you call it as a weighted factor loading. right? So in the next step, what we do is we find out what is called as a cross product matrix P2. What is that? See, we create a matrix like this, having x1 to x6 here, x1 to x6 here. Here, if I want to find out this value, how do I do it? I go to this weighted loading factor, 1 and 1, you are focusing on 1 and 1. That means I should multiply this number 0.83561 multiplied with the same number, because 1 and 1. When I come across this 1 and 2, what I have to do is this number 0.83561 into the second number 1 and 2. These two numbers I have to multiply. That is called as cross product. Then this is what? 1 and 3. That means this 0.83561 multiplied by 0.43643. You get this. Then this one, 1 and 4. This number multiplied by this number. Likewise, whatever numbers are occurring here, 2 and 5 means go to 2, 0.85882 multiplied by 0.63495. You get that number. Suppose you take this negative value. Why this is negative? Let us see. Third number and sixth number. Third number is this 0.49643. Sixth number is negative number. So you multiply negative into positive, you get negative number. So this is called as cross product matrix. You call this as P2, right? In the next step, we find out what is called as a residual matrix R2. How we find that? It is obtained by subtracting the cross product matrix, that is this matrix, from the R1 matrix. R1 we already found. This matrix subtracted with this cross product matrix, this matrix. That will give you this residual matrix. Means, let me choose some value. Let me choose this value. Negative 0.430, this position, that is sixth row and first column. Negative 0.430 minus of 0.412. Minus of minus, it becomes plus. So you rounded up with negative 0.018. So now you have to do the same thing for all the values, R1 minus P2. It is nothing but a matrix subtraction, what we are doing. Then now you may notice here, where all negative numbers are there, everything has to be converted to a positive numbers. So what are the weights then? Let us check this. If you look into the weights, you may notice here negative, yes, here negative, here negative, here negative. Means x3 is having negative, x3 contributes negative, x4 is also, x2, when you come to x2, it is actually x3, x5, x6, already considered, x3, x5, x6. x1, if you come, x3, x4, x5, x6, already that is also considered. That means only these columns 3, 4, 5, 6 must be reflected, and the reflected matrix R2 dash. Here, if you compare this matrix with this matrix, you may notice only the negative signs got changed to positive signs. Again, you do the same thing, column totals, then the grand total, then taking a square root. Again, the same unweighted factor loading you calculate. How do you calculate? Write down these SJ values in this first column, second column rather. Then you find out the unweighted factor loading. How do you do it? This SJ divided by this means 0.689 divided by this, 0.585 divided by this. You write all those things. Then weighted means here you identified positive 1, negative 1, negative 1, negative 1. Means 3, 4, 5 are negative. Rest first 2 and second are positive. You assign those values. I mean, multiply those. 1 into this, you get 1. Same thing. 1 into this, negative 1 into this, negative 1 into this, negative 1 into this, negative 1 into this. You get this, right? Next step is again to find out the cross product. Already we know how to find out. If I am coming to first row, first column, I have to multiply the first number into first number. Coming to this, for example, this is, I need to multiply fifth number into fourth number. Fifth number into fourth number. I will get a positive because negative into negative. Do I get? Yes, it is positive. So identify the cross product matrix. Next is residual matrix, like previously how we did, same thing. Means R2, whatever is R2 matrix, this matrix, minus the cross product matrix, P3 matrix. You get this residual matrix. Again, identify which are all variables to be reflected. So if you come into x1, x2, x3, x2, you may notice x2 already considered, so you ignore x1 then. x3 you considered here, x4 you considered here. So that means you may notice 2, 3, 4, 5, 6 must be reflected. That means the signs or the weights will be 1, all or -1. That is what the weights will be. Right. The reflected matrix means all these without this signs. Again, you calculate the SJ values. Again, you calculate the grand total. You take a square root of that grand total. Then you form this unweighted factor loading, which we know how to do it. This value divided by this value to get this. Then weighted, as we spoke about already, only the first will have +1. The rest are all having -1 as the weights. So you accordingly you put the signs. Now you have done 3 iterations, right? Because we landed up with R3 dash now. 3 iterations are over. Now you can stop doing further. You can write variables x1, x2, x3 up to x6. There are 6 variables we know. Whatever we identified the weighted factor loading, let us copy that. Factor 1, what was there? Very first table, whatever we did. I think here, these numbers. I will be out writing all these numbers. 0.83561. I would have written the same thing. Yes. Then factor 2 means it starts with 0.2482. Where is that? Here. All these 6 numbers I need to write over there. Sorry, here. And then factor 3 is available here. Copy that. Now, in this, you mark, you highlight in each variable, whichever is the largest, irrespective of the sign. 0.83561, 0.24, 0.26. So highest is 0.83. In this, which is the highest among these three, 0.85. In this, which is the highest, irrespective of sign, means it is 0.64 only. Highlight that. In these 3 values, highest is 0.65. In these 3 values, highest is this. In these 3 values, highest is this. You are seeing all those things without considering the signs. Now, what do you mean by this eigenvalue? Eigenvalue is the sum of the squares of each factor. Means this 0.83561 square plus this 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 square. You will get this 0.27. Likewise, you do it for each factor. Sum of the squares of rows actually. Each factor means sum of the squares of rows. And this communality H, which is called as H square, is nothing but sum of the squares of each column, means 0.83561 square plus 0.2482382 square plus 0.26075 square. You get this. So communality is the sum of the squares of each variable. So each variable means each sum of the squares of the each column. This square plus this square plus this square. Right. Then the total variance, when I say total variance, it is the number of variables. It is 6. Common variance is the sum of this H square. Whatever you got by adding all this communality, whatever it is, that is your what do you call total variance. Now you can factor number 1. So you already highlighted, right? Which are the variables you highlighted? X1, X2, X4, and X5. You may write those X1, X2, X4, and X5, right? X1 denotes what? You can bring back the description which was given in the original question, write down. And if you look into fuel efficiency, life, quality of spares, breakdown, all these are technical related. So you call this factor as a technical factor. This second factor, if you look into, only one is highlighted, third only one is highlighted, and the X6 is related to price. So straight away you say price factor. And this X3 is related to handling convenience. So you call just as personal factor. So you brought now 3 factors which contributes this. Then here you can calculate what is called as a proportion of total variance. How do we do that? Proportion of total variance means this, what do you call, 2.75 662 divided by 6. If you do that, I think you will get that 0.46. Let's check that. 2.75662 divided by 6, you get 0.46. That is what is written here. Similarly, this one you get by dividing this by 6. So this is basically, I can say 2.7, I'm sorry, this 0.46, how do we get it? I can say 0.46 is obtained by 2.75662 divided by 6. Likewise, even this 0.26, I can say it is obtained by 1.56833 divided by the number of variables, which is the total variance. Whereas the common variance, how do we calculate? This 0.49 we get by taking this 2.75662, that eigenvalue, divided by the common variance, which is 5.59356. Likewise, you get that 0.49. Similar is the case for 0.2, 1.56833 divided by this, you get this. Means you can say, if I consider total variance, then the contribution of factor 1 is 46%, factor 2 is 26%, and factor 3 is, what do you call, 21%. If you consider this, what do you call, common variance, then you can say it is 49% in factor 1, factor 2 is contributing 28%, factor 3 is contributing 23%. Likewise, we can conclude. So this is what is about factor analysis. In case if you find this video to be useful to you, I request you to please like, share, and subscribe to my channel. Thank you.